All right, class, this is number 1A on your review. So we have this word problem here. We need to figure out a matrix, be able to construct the formulas and create a matrix to solve this system. So you manage a clothing store and budget $6,000 to restock 200 shirts. You can buy t-shirts for $12 each, polos for $24 each, and rugby shirts for $36 each. You have twice as many rugby shirts as polo shirts. Formulate a system of equations to determine how many of each type of shirt you buy. So I immediately see the three equations that I'm going to have here. One of them is going to have to do with the money, the $6,000. One of them is going to have to do with the total number of shirts, the 200. And one will be about this: you want twice as many rugby shirts as polo shirts. So let's start with setting our variables. I'm going to say t-shirts are T. So T equals t-shirts. T equals t-shirt. And then I'm going to say P equals polo. And I'm going to say R equals rugby shirt. And now I'm going to create my three equations. The first equation is going to have to do with the money, the $6,000. And so I know the total is going to be $6,000, and I need to use the dollars for each variable. So 12 for T, so that would be 12T plus 24P for polo plus 36R for rugby. And that will add up to 6,000. So 6,000 on there. So that's my first equation. The next equation has to do with the 200 total shirts. And that would just be, because T represents the number of t-shirts, R is the number of rugby, P is the number of polo. So T plus P plus R is going to be equal to 200. All right. And then my last equation is I have twice as many rugby shirts as polo shirts. So that means the rugby shirts are twice as many as the polo shirts. So you would write it like this: the rugby shirts are the bigger one. There's more rugby shirts. So they're equal to twice as much as the polo shirts. But to set this up in a matrix, though, if I wanted to set up a matrix over here, the first thing I would need to do is I need to line them up. Like over here, I'm going to make my matrix. It needs to be T, and then P, and then R inside your matrix. They got to be in, every formula needs to be in the same order. Equals your constant C over here. All right. So I need to get the formulas. This one's already in T. See, this one has T, P, R number. This one has T, P, R number. This one needs to be in that order as well. So I need to work on this bottom formula right here. I need to move the 2P to the other side. So minus 2P to both sides, and that cancels out. And I need P before R, right? T, then P, then R. So I need negative 2P plus R. See, I put the P before the R because the P is before the R in our formula, equals 0, because 2P minus 2P is 0. So let's go ahead and write the matrix now. The top equation is 12T plus 24P plus 36R equals 6,000. The middle equation is 1T plus 1P plus 1R. See, T plus P plus R equals 200. And the bottom one, see, there is no T, so you would put 0T, and then there's minus 2P, negative 2P, and then there's R is 1, is equal to 0. And that would be my matrix to solve this equation. They just wanted us to come up with a matrix. You didn't actually solve it. So that is number 1A.